Alright, Algebra 2. We talked about this a little bit in class today, so this may look familiar to you. So those of you who want to fast forward in the video probably can. But simple little inequality. The absolute value of x is less than 3. Now I gave you the little hint in class today, less than. Alright, there's my little clue as to what word we're going to choose. I know, it's corny, but it works. You're looking for all of the values that are within 3 units of 0. All the values that are within 3 units of 0. Let me write that down. All values within 3 units of 0. That's why the picture of the graph is going to make sense to you. Now, when we solve these problems, we want to isolate the absolute value bars. Clearly, the absolute value bars have been isolated. They are by themselves. Then I'm able to split it into 2 inequalities. The first one looks an awful lot like the original. The second one, however, has something different. When you change the opposite side to its negative, the sign flips. Right? So, and we're looking for what they have in common. So, greater than -3, less than +3, and what they have in common. Now, remember what I wrote up here? All values within 3 units of 0? That's it, right there. Right? 0 is in the middle. All the values within 3 units of 0. Now when we switch gears to greater than, here's my little helpful hint for this, greater than, we're choosing the word or. And we want all the values, the first one, see the absolute value bars are isolated, that's good news. So we can split it into 2 inequalities. The first one looks exactly like the original without the absolute value bars. The second one, when you switch this to the negative version, you switch the sign, right? Greater than 3, that would be this part. Less than -3, that would be this part. Or means find all the values that make that true. Well, you have to include both of them in your final graph. So we want all the values that are more than 3 units away from 0. More than 3 units away from 0, like 4 and 7 and 25 million and -10. And all of those are more than 3 units away from 0. Right? 0 being in the middle there. Now keep in mind, the ones that could be written as and. This isn't true for the or, but the ones that can be written by and could also be written like this. Now you see this part over here? That's right there. If you would turn this one around or flip it over, the -3 being on the left side, the point still goes to the -3 and the x there, and then take this, you can see that right here. Now that little trick right there only works with the word and, it does not work with the word or. So you have a minimum, a less than, a variable, a less than, and a max. And those symbols could be less than or equal to's. Okay, they wouldn't have to be strictly less than's. They could be less than or equal to's. But that's how we can rewrite an and. So that can be written like that. We're going to solve a couple examples here. Some of these will involve, so here's an example, 3x plus the absolute value of 3x plus 6 greater than or equal to 12. Okay, first of all, are the absolute value bars isolated? Of course they are. Okay, I can clearly see nothing is being added or subtracted or multiplied on the outside, so I don't have to worry about that. I am ready to split this up. So the first inequality looks an awful lot like the original. It's a greater than, so this is the word or, greater than. 3x plus 6 is less than or equal to negative 12. Now, if you choose the wrong word on the test or quiz, is that going to be, are you going to lose credit? Sure you will. Plus, your graph's going to be wrong. So it's really important that you know what that symbol means and which word to choose. Okay, of course we're going to subtract 6 from both sides. 3x is less than or equal to negative 18. 3x is greater than or equal to 6. And of course we're going to divide by 3. X is greater than or equal to 2, or x is less than or equal to negative 6. We didn't divide by a negative number, so we didn't have to flip the sign on anything. So let's see here. We got a negative 6 and a positive 2. Less than or equal to, solid circle going to the left, greater than or equal to 2, solid circle going to the right. It's the word or, so I want both of them on my final graph. It's not what they have in common, it's not in between, it's both parts on my final graph. Okay. So what if the absolute value of 2x plus 6, what if the absolute value bars are not isolated? Well, get rid of that thing for one. Move it on over. As I've said to you in class, some kids want to distribute the 3. There's no property like that. Do not distribute. There's nothing like that. How are we going to get rid of multiplying by 3? Of course, we're going to divide by 3. And I'll squeeze that in here since we're not distributing. So we have absolute value of 2x plus 6 is less than 8. Now it's ready. Split it up. 2x plus 6 is less than 8. It's a less than, so that means I'm choosing the word and. 2x plus 6 greater than negative 8. Make sure you're switching both the sign on the opposite side and the inequality symbol right there. Some kids do one but not the other, and it causes them to lose credit. Or they get confused and frustrated on what's going on during quiz or test. So of course we're going to subtract 6 from both sides. So 2x is less than 2. 2x is greater than negative 14. And we're going to divide out the 2. Whoops. X is less than 1. And x is greater than negative 7. So when we think about our number line, less than 1, greater than negative 7, and we're using the word and, so that means everything in common, and so we want everything from here to there. Okay, so you've watched the video, you've taken the notes. I need you to do 1-5. Let's see here. Let me check something here. How about 1-5, 16 through 32? Yep, let's just do 16 through 32 evens, okay? So take the notes and do 1-5, 16 through 32 evens tonight and bring those to class tomorrow. Bring them finished. As best you can, you know what I mean. Okay, see you in class.